Hello, today I'm going to discuss LeetCode question, number of longest increase in subsequence. So, given an integer array, return the number of longest increase in subsequences. So for this first example here, the two longest increase in subsequences are 1, 3, 4, and 7, and 1, 3, 5, 7. And while this example is sorted, it could also be unsorted. So if you have like 5, 3, 1, 2. So in this case, the longest number of longest increase in subsequences would just be 1 over here, just 1, 2. And also what we want to do is count the number of longest increase in subsequences. Okay, and the second example here, where we have all 2's, the length of the longest subsequence would just be 1 because it's not strictly increasing. They're all of the same value, and since they're the longest increase in subsequence is 1, and there are 5 of these. Okay, of just 2, 2, 2, and 2, 2. Okay, so let's build a decision tree for this first of all to see how we can think about this. We'll just take this first example here of 1, 3, 5, 4, 7. So in the decision tree, if we look at the first position of value 1 over here, then what we want to do is we want to iterate through the rest of these values here in the next positions and see if it's greater than 1, and if it is, then that could be part of the longest increase in subsequence. So we have 1 here, and then 3, and then 5, 4, 7. Since they're all greater than 1 here, they're all possible contenders to be part of the longest increase in subsequence. And if we continue here, for 3, we have to look at the rest of the array here too. So we look at 5, 4, 7, also all possible contenders since they're all greater than 3. And if we look at 5 here, we can look at 4 and 7. We want to stop here at 4 because it is not greater than 5, so it cannot be a contender in the longest increase in subsequence. And if we look at 4, we can see that the possible contender is 7, and then 7 here, there's nothing after that. Okay, and then what we can do is go to the next subsequence here, next element I mean here, of 3, and build a decision tree for that. So 3, and then do the same things as we did here. Look at all the positions after 3. So 5, 4, 7, they're all possible contenders to be part of the longest increasing subsequence. And then we do a similar thing here. 5, 4, 7, we want to stop at 4, etc., etc. And then until we build this tree, we can calculate the longest increase in subsequence. In this example here of the tree, it would be 1, 3, 4, and then it would be 7. And then we have also another one of 1, 3, 5, 7. So this decision branch here, it's getting a little messy, would be 1, 3, 5, 7, and then we have 2 longest increase in subsequences of length 4, and then that would be our answer. So calculating all the branches of this decision tree here would be it would be exponential time, and that takes too long. And we can see we have a lot of repeated work here. So if we're calculating the increase in subsequence of 5, we do that here, we do that here, we also do that here. So there's a lot of repeated work. But how can we reduce this repeated work here? Well, if we want to know the subsequence of 3, we also need to solve the increase in subsequence of 3. We also need to know the increase in subsequence of 5, and then increase in subsequence of 7. So why not just start at this last element here? Calculate the length of the increase in subsequence starting from this last element here. And then as we go backwards in the array, if the this value is less than the value of in the positions in front of it, that could be part of longest increase in subsequence. That could be a contender. And then we do similarly for the rest. So we calculate the longest increase in subsequence for all these positions here. And then finally, we can find the longest increase in subsequence. But we want the number of longest increase in subsequences, not the actual longest increase in subsequence. So while we have a way to calculate the longest increase in subsequence, we need to calculate the number of longest increase in subsequences. So what we can do is count how many times it took to get the longest increase in subsequence of a certain position. So for example, if we take 3 here, so we would have 3, 4, 7, and 3, 5, 7. So, and we obviously know at this position the longest increase in subsequence is 3. So what we do is this guy's increase in subsequence is 1, this guy's is 2, and then 3, and then how many times is it 3? It's twice. So 2 times we were able to calculate the longest increase in subsequence of 3. Okay, so we'll do this. So this is the method that we will approach. So now that we have an approach to calculate the number of longest increase in subsequences, I can draw out how we're going to exactly do this. So if we have example 1, 3, 4, 7 here, so we'll have a DP array to count the longest increase in subsequence, and then we'll have a second array here. Count number ways to L longest increase in subsequence. Let's write that cleaner. So for each element, we're going to count, whoops, this is 5. We're going to count the number of ways it's going to take to get to that longest increase in subsequence of that element. So for DP, we're just going to initialize everything to 1 because the longest increase in subsequence of an element with itself is 1. So we're going to start at the end here and look beyond it and see if there are any larger elements, and then if there are, we're going to take the max of dpi and dpj, where j is the index further along, where the value is greater than the current value we're looking at, plus 1. So for 7, since there's nothing after it, we can skip this. So with 4, since we have one larger element, 7, this will be max dp of I, max of the current element, and that element that's larger plus 1, so this will turn into 2. Similar for 5, we have the 1 largest element of 7, so this will be 2. For 3, we have all 3 of these are larger. So to get the longest increase in subsequence, we'll look at 5 first. Maximum of that is 1, 2 plus 1, so it'll be 3. Similarly for 4, it's 3, but it's already the largest, so we'll keep that there. And for 7, it'll be 3, 1 plus 1, and 3 is obviously bigger, so we'll keep that 3 here. So longest increase in subsequence of 3, the value 3 is 3, so 3, 5, 7, or 3, 4, 7. And for 1, similarly, since 3 is bigger, this will be 4, because 3 plus 1 is greater than 1. And the rest of these, while they're bigger than 1, their increase in subsequence value will be less than 4. So now we'll look at the second array here, count number of ways to longest increase in subsequence. So what we want to do is similarly start from the end and look further. And if there is a value larger than the value we're looking at, what we want to do is add. So first of all, if the value of the DP is 1 here, then the number of ways to LIS would be just 1. It would just be itself. There's only one way to get it, and it's itself. And for 4, since 7 is bigger, and yeah, how we want to do count number of ways to longest increase in subsequence would be, it'd be if dpi is equal to, since this is the largest increase in subsequence, dpj plus 1. So what this tells us, dpj plus 1, is we got the next value in this increase in subsequence from this position here. So, and that is one way to get the longest increase in subsequence we see here. So if this is true, and we need to check if the value 4 is greater than 7, and nums I, or sorry, if 7 is greater than 4, less than nums j. So if this is true, then increment this by 1. So this would just be 1 here. Okay, and I should mention initially all these would be 0. Similarly for 5, we see 7 is bigger, so there's only one way to get that increase in subsequence value of 2. Okay, now let's look at an interesting case. So value of 3. So we see here that the longest increase in subsequence of this value 3 is 3. And we want to count the number of ways we got to this longest increase in subsequence. So obviously we got it from, we could get it from 5, and we could get it from 4, because the two possible subsequences are 3, 5, 7, and 3, 4, 7. So since 5 is greater than 3, and 2 plus 1 is equal to 3, we increment this by 1. Similarly for 4, since 4 is greater than 3, and 2 plus 1 is 3, we add this, plus this by 1, so that turns into 2. And for 1 here, we want to count how many ways it takes to get to the longest increase in subsequence of 4. And we see 3 is greater than 1, and 3 plus 1 is 4, so we add plus 2 here, because since it took 1 way to get to position 4, or 1 way to get to longest increase in subsequence of 4, 1 way to get to longest increase in subsequence of 5, 2 ways to get to longest increase in subsequence of 3. This will also be 2 ways of getting the longest increase in subsequence of 1, because it'll be 1, 3, 5, 7, and then 1, 3, 4, 7. So we want to increment this value here. Okay. And finally, since we have this 2 here, so finally what we want to do is get the longest increase in subsequence, which is 4, and then throughout the rest array, just count how many ways we were able to get to this 4. Just iterate through this count number of ways array and add the number of ways we were able to get to this longest increase in subsequence. So it'd just be 2 plus, this is the only 4 here, so it'd just be 2. And yeah, that'd be the answer. The answer would be 2, as we see here. This time complexity would be O of n squared, because to get the larger elements after the position we're looking at, we have to have an inner loop, and we have to look at each element twice. So if you have 7 here, if you have to look at everything after it, 4 here, look at everything after it, 5, look at everything after it. So we'll have an outer loop and an inner loop, and the space complexity would be O of 2 of n in my solution, to have 2 arrays of length nums. So to code this solution up, first I want to initialize my DP array and initialize to 1 for all values within the range nums, just to represent the position itself having a subsequence or a sequence length of 1 of itself. And then initialize a second array. I'll just call it num ways to longest increase in subsequence. Just to be really explicit here. So it counts the number of ways to get to that longest increase in subsequence that was calculated in this DP up here already. Initialize to 0 first. Initialize all the elements to 0 first for each position in the array nums. Okay, now I want to loop the array nums backwards, so I'm going to start from the last element. So for I in range and nums, nums minus 1, because I want to start from the last element, 0 indexed. Okay. And what I want to do is starting from that index, loop forward. So if I'm in position 2, I want to loop starting from position 3 and beyond. So for j in range I plus 1, the index after the one we're looking at in this outer loop here, all the way to the end of the array nums. Oops. And if nums j is greater than nums I, then I want to initialize the dp at that position I to be the max of the longest increase in subsequence at position I, and longest increase in subsequence at position j plus 1 to account for the element we're focusing on right now. Okay, so that calculates our dp for each position here, and then so all the dp for that position has been calculated. What I want to do is also calculate the number of ways to the longest increase in subsequence of that dp position that we just calculated. First I want to start off by saying if dp at position I is equal to 1, that means there's no increase in some element after, and the largest increase in subsequence is just itself. Then I want to initialize, let's copy this here, of I to be 1. There's only one way to get to the longest increase in subsequence, and that's just itself. Okay, and else what we can do is again loop here, loop everything after the position we're looking at, and if nums j greater than nums I and dpj longest increase in subsequence at j plus 1 is equal to dpi, the longest increase in subsequence that we just calculated for I here. So that means at the element in position j, that was a possible way to calculate the longest increase in subsequence at dpi here. What I want to do is copy this long array name here, I plus equal num j. Okay, so if we have example here 1, 3, 5, 4, 7, we calculate this guy's longest increase in subsequence to 3, and its number of ways to that longest increase in subsequence is 2 via 5 and 4. And if we're looking at 1, we want to increment, so it would be number 2, because it was able to have the longest increase in subsequence via 3, 5, 7 and 3, 4, 7, and for 1 the longest increase in subsequences would be via 1, 3, 5, 7 and 1, 3, 4, 7. So that's why we want to add the number of ways to longest increase in subsequence of j. Okay, so this loop here should populate our dp and number of ways to longest increase in subsequence arrays, and this would be of O of n squared time, because we're visiting each element at least twice here, where we have an outer loop and an inner loop. So what we want to do here, let's have max subsequence length equals to the max of dp, and result have that to 0, and for I in range length dp So if dp at position I is equal to this max subsequent length, then update result to be number of ways to that longest increase in subsequence at position I. And then finally return count. Yeah, I want to loop over here, and just in case at multiple positions of DP we have the same longest subsequence. Okay, that should work there. Let me see what the problem is. DPI result of sequence. Oh, return result, not count. Let me first check if it compiles. Okay, now I'll submit. Okay, and that's pretty much it. Thanks for watching.